Ugly and unique. Everything about the Boeing F-32. The Common Affordable Lightweight Fighter Project, or CAF, was a program initiated by the U.S. in 1993 with the intention of retiring a large number of older jet aircraft, such as the F-15s and F-16s, and providing a base for the efficient and economical development of the next generation of U.S. jet aircraft. In 1994, CAF was incorporated into the Joint Strike Fighter Program, also known as JSF. In this video, we'll discuss everything about the ugly and unique U.S. aircraft, the Boeing F-32, which was supposed to meet the needs of U.S. Air Forces and Navy next-generation aircraft. The F-32 is a concept demonstrator aircraft built by the aircraft manufacturer Boeing for the U.S. Department of Defense's Joint Strike Fighter Program. After the JSF program was launched, the bidding for the new aircraft manufacturing started in 1994. During the first phase of this project, which included concept aircraft designs to be submitted to the Department of Defense, a number of different companies participated. On November 16, 1996, contracts were given to Boeing and Lockheed Martin for the production of 2 concept demonstration aircraft, or CDAs, each. These fighter aircraft were expected to demonstrate conventional takeoff and landing, or CTOL, takeoff and landing from a carrier, CV variant, and short takeoff and vertical landing, STOVL. In addition to that, it was expected that they would feature ground demonstrations of the equipment installed on a production representative aircraft, such as the Preferred Weapon System Concept, or PWSC. It was a significant break from the way things had been done on prior projects that the corporations were not allowed to use their own resources to finance the project. Both companies were given a grant of $750 million to develop their respective 2 aircraft, including avionics, software, and hardware. This restriction not only encouraged the use of low-cost production and assembly techniques, but also prevented either Boeing or Lockheed Martin from going bankrupt in their bid to win such a crucial contest. Design. The strategy that Boeing implemented in order to gain a competitive edge was to deliver much cheaper production and life cycle costs by reducing the amount of variation that existed between the many JSF variants. As a result, the X-32 was developed with a sizable delta wing that is made of carbon fiber composite in one piece. The wing had a span of 9.15 meters, a leading edge sweep of 55 degrees, and the capacity to hold up to 20,000 pounds or 9,000 kilograms of fuel. The high sweep angle served 2 purposes. It allowed for a thick wing section to be employed while still giving a minimal amount of transonic aerodynamic drag, and it provided a good angle for conformal antenna equipment that was put on the wing. Both of these purposes were accomplished. Constructing the wing would be difficult, to say the least. Because it would only require the addition of a thrust vectoring module around the main engine, the direct lift thrust vectoring system was the one that Boeing decided to go with in order to meet the short takeoff and vertical landing requirement of the Marine Corps. This decision was made thanks to the complete on-cost strategy. However, this decision required mounting the engine directly behind the cockpit, which shifted the center of gravity forward from where it is typically located in jet fighters toward the rear of the aircraft, which made it possible to hover in a neutral altitude posture. The background behind this design was that in the 1960s, Boeing had already floated the idea of developing a comparable supersonic fighter aircraft equipped with a mid-center of gravity mounted engine that included vectored thrust nozzles. However, this idea was never developed further than pictures that were published in Aviation Week back then. One of the impacts of the selection of the direct lift system was the large chin-mounted air intake. During the phase of zero horizontal velocity, when the aircraft was unable to take advantage of ram air pressure, this was necessary in order to ensure that the main engine received a sufficient supply of air to produce the necessary push for hovering. The enormous intake had a number of unintended consequences, one of which being the potential for direct viewing of the compressor blades to radar. Another consequence of it was that it made the aircraft look incredibly ugly. For direct viewing of the compressor blades to radar, the use of changeable baffles that were designed to block incoming radio waves without adversely affecting airflow was one possibility for resolving the issue. First flight. Boeing's concept demonstrators were shown off for the first time on December 14, 1999 at the company's plant in Palmdale, California, in front of 5,500 guests. Because of the massive delta wing design of the X-32, Boeing demonstrated STOVL flight and supersonic flight in separate configurations. The STOVL mode required that some parts be removed from the fighter. However, the company promised that their conventional tail design for production models would not need separate configurations. The F-32, which was intended for CTOL and carrier trials, took off for the first time on September 18, 2000, departing from the Boeing facility in Palmdale and heading in the direction of Edwards Air Force Base. Before taking off at a speed of 150 knots, or 250 kilometers an hour, 170 miles per hour, at about 8 in the morning, the aircraft, which was piloted by Boeing test pilot Fred Knox, used 2,200 feet or 670 meters of runway. Because of a very minor hydraulic leak that was found shortly after takeoff, the duration of the flight was reduced from the anticipated 30 to 40 minutes to only 20 minutes. During the course of the flight, the aircraft reached an altitude of 10,000 feet, that is 3,000 meters, achieved a speed of 200 knots, or 370 kilometers an hour, or 230 miles per hour, and reached an angle of attack of 13 degrees. In spite of the fact that the flight time was cut short, approximately 80% of the planned test points were accomplished. The X-32B STOVL version successfully completed its maiden flight on March 29, 2001. The aircraft took off from Palmdale and flew to Edwards Air Force Base. The trip lasted a total of 50 minutes. Through the use of thrust vectoring on the jet exhaust, the X-32B was able to achieve STOVL flying in a manner that was similar to that of the AV-8B Harrier II. By maintaining a consistent engine match, which was made easier by the control system algorithm keeping a fixed total nozzle effective area, a smooth transition was produced. As a result, the engine was not aware that numerous nozzles were being opened and closed off in order to finish the transition. Failure. So why wasn't the F-32 chosen for the final roster? To begin, the direct lift system was prone to pop stalls, which is a severe defect that occurs when hot air is sucked into the engine. The government was also concerned about whether or not the F-32's engine had the power to maintain the aircraft's declared maximum takeoff weight of 50,000 pounds. Worse yet, 8 months into the competition, the Navy requested that the standards for the Joint Strike Fighter's aerodynamic performance be changed. The engineers at Boeing were able to make a few minor adjustments to the tail, but it was too late to significantly rebuild the delta wing to properly conform to the new JSF specifications. In spite of its plan to cut costs, Boeing ended up building 2 prototypes, each of which demonstrated a different aspect of the JSF's specification guidelines. These prototypes were a conventional flight model that demonstrated supersonic performance and an X-32B short takeoff and vertical landing variant. Both of these models were able to meet the JSF's requirements. Even though competing company Lockheed Martin's X-35 demonstrator model was already capable of both of these things, Boeing asserted that these features will be unified with the serial F-32. Since the JSF rules made the capability of vertical takeoff and landing a central pillar, the Pentagon simply did not agree with Boeing's vision for the integration of STOVL technology. In 2001, the conclusion was reached that the Lockheed Martin X-35 was superior to the Boeing X-32 in every respect. However, it is really difficult to determine whether or not the Department of Defense, or DoD, made the correct choice. It is highly likely that Boeing would have encountered broadly similar problems as those that have plagued the F-35 program for the past 10 years. These problems include rampant budget concerns, as well as the implicit technical challenges of implementing cutting-edge technologies such as sensor fusion. Do you think the Department of Defense made the correct decision by declaring the Lockheed Martin F-35 the winner? If you like this video, make sure to smash that like button and subscribe to our channel for everyday military updates. Don't forget to leave a comment in the section below. Thanks for watching.